deciding what the exact threshold is going to be. Don't freak out if you don't have 100% on there. The threshold is probably going to be 90 to 95%, right, in terms of completion of the design book. So if you miss a section, you're probably okay, right? But you do need to have completed at least most of the sections of the design book by Thursday. Like I said, that's what I'm going to do first thing in the office Friday morning, and I guarantee that I probably wake up earlier than you do on Friday. Be good to have that done by Thursday. Of course, the first lab assignment is due 1 week from today. I had a couple things that I wanted to say about that really quickly. For starters, the lab instructions suggest that you use ModelSim as your simulation, which is perfectly fine. I believe that works on the lab machines. You actually saw me struggle with ModelSim up here on Thursday of last week, and I still struggle with ModelSim. So there is a solution to that. If you can't get ModelSim working on your machine for whatever reason, there's an alternative version that you can use called iSim. That is perfectly okay. You are free and welcome to use iSim. I don't believe that it's going to cause any problems for future labs, but if it does, I will be sure to let you know on the lab write-ups for that particular lab whether that will cause an issue. ModelSim is the better version of the two, but I've had a heck of a time. I spent a good portion of my weekend trying to get ModelSim set up, which was not how I wanted to spend my 3-day weekend. So, if you're having those problems, you can use iSim, no problem. The other thing I wanted to remind you about with the lab is if you haven't started it already, you should probably think about doing that pretty soon. The main reason I say that is you have to demo your lab to a TA to get credit for it, right? And if a whole bunch of people show up to TA office hours on Monday night or Tuesday and the TAs don't have enough time to get to everybody, that is not an excuse. I'm going to say tough luck. You have plenty of time to demo these labs. The TAs, they're only human. They can only process people in a certain amount of time. If they run out of time, if they have to leave and you don't get your demo in, that's on you. That is not on the TAs. That is not on me, right? So please, please, please start early. Demo early. Especially if the TAs call something out on your demo, right? Then you're going to have to go fix it and demo again. So leave yourself some time if you need to re-demo, because that is required. If you don't demo, then I'm not going to accept your lab. Any questions about that process? Please, 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 please start early, especially for later labs when we start doing some more intense stuff. That is going to be an absolute, absolute must. We're doing pretty good on grading. We've got a decent chunk of the first assignment already graded, and I hope to have the rest of them graded by the end of this week. So you will get them back hopefully by Thursday. If not by Thursday, then by Tuesday at the absolute latest. So any questions for me about lab stuff? Yes, in the back. TA office hours. You can also demo during my office hours if you want to as well. Yes, but you must demo to the TA or myself. We need to sign off on that sheet that's on the lab assignment, right? You have to print off that sheet and give it to the TA so that they can fill it out during your demo. And then you'll staple that to the front of your lab and turn it in with everything else. Okay? Any other questions? Yeah?
If there's something wrong with the lab, when we demo it, do we use points for that? Or is it just
yeah, so if you look at the form, the TAs grade everything out of 3 points, basically. So there's a few different components that they're looking for. They actually kind of pre-grade your lab, and then we go back through and do a more fine-grained grading later on after you turn it in. So they're going to, at a very high level, grade your lab from 0 to 3 for all the components that you're supposed to do, including the demo. If there's something wrong, you can re-demo it. I'm not opposed to that, right? But again, the TAs have limited time, so, I can't have, if they run out of time and you don't get around to it, tough luck, and a re-demo is going to take less priority over somebody who hasn't demoed at all. So, please, 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 I cannot emphasize enough. I would like to see people getting their labs demoed Thursday and Friday this week. I think that's definitely possible. Even if you haven't started yet, I think it would be definitely possible to demo your lab on Thursday. Actually, I guess we don't have anybody in on Friday. We do have people in on Sundays, so it would be a good time to demo too. So, please, please, please start early. Any other questions that I can answer? What about material questions? It's getting a little trickier, isn't it? Especially last time we had a little tricky stuff. Today is going to be fun as well. It's going to be more boolean algebra stuff. We kind of ran out of time last time. I'm hoping that we might have some time to go back and pick up some of those problems that we didn't have time to get to last time. We'll kind of see how it goes. I did prepare some review problems, as I like to do. So I guess if there aren't any more questions, we'll hop into those. So the topics that were covered in the previous videos and in the textbook were Minterms, some of Minterms form, simplification, which is what we're going to spend a fair amount of time talking about today, I have a feeling, and timing diagrams. We're going to play around with all these things today, and truth tables too, for that matter. So here we go. I'm giving you this boolean expression, and I ask you to rewrite this expression in a few different ways, right? Rewrite it in some of products form, rewrite it in some of Minterms form, and then I ask you to simplify this. Now when I say simplify, traditionally I mean rewrite this expression so that it uses the fewest amount of logic gates, right? That's what it means to simplify. So you don't necessarily have to start from some of products or some of Minterms form to simplify this thing. Just keep that in mind. It might be easier to start from one form over another. Choose the one that will be easiest to you. Take a few minutes. Talk to your neighbors. Ellie and I will be around if you have any questions, and we'll discuss as a group in a little bit.
Yeah, you're going to turn AC prime to 40. There you are. Well, you might not. That's a good person. I like this one.
Oh, yeah. Yeah, that was like...
Well, just get it, I mean, it's not, it doesn't.
Yes. Yeah, I took 2
then you have Thursday. I think so.
So no options.
what we have. What was your name?
Corey.
Corey, thank you. Thank you, Corey, for putting this up on the board. Where are we starting from? What form is this? Some of Minterms form, right? So we'll maybe come back to some of Minterms form in just a little bit and talk about how to get things in that particular form. But first, let's take a look at the simplification that's up here on the board. So it looks like the first step is what? What's happening here? What algebraic property am I applying? Is Corey applying? Rather? Anybody? Yeah. Yes, well, identity somewhat, right? But before we get there, we're actually factoring out this B or B not property, right? That's a very powerful tool when it comes to simplification, right? That was what was talked about in the textbook, and also what I talked a little bit about in the video. If you can find two terms that differ by one input variable, then we can extract this out, right? We can extract that out, and then these go away via the identity property, via the property of ordering something with its opposite. So it looks like these match up pretty well in terms of these terms. We've got 8 terms total, and they all have B's and their complements in them. So that looks pretty good. And then these all fall out. We get to do that a couple more times. This one has an A that's different. This one has a D that's different, right? So those fall out, and then we end up with this particular expression here. Can we simplify this any farther? Anybody see anything? Yeah. Yeah, again, we have kind of an identity here. This C naught doesn't really matter in this particular case. I believe that was an identity that we proved on Thursday, was it not?
Well, that was like A or B, A naught. Like, in this case, you have two different, like, you have C and T naught, and then you have, you know what I'm saying? Like,
Well,
would you do generalize?
let's try and prove it a different way, right? We can write out a truth table for this. That's the best way to prove anything, is to construct a truth table. So let's just try it that way and see if we can apply a truth table to this. So we know that C and D has to be true. So we've got 3 variables, A, C, and D. D is gone entirely, yet I wrote it up on the board anyway. Right? So we know that C and D have to be true in order for this to be true, or A and C naught have to be true, and there's a whole bunch of different possible combinations for A and C naught. Well, I guess not a whole bunch, right? 1, 0, 1, 1, 0, 0. There's 2 different combinations here, 1, 1, 1, right? So these are the only 4 possible combinations that could result in true in this particular expression, right? Does everybody agree with me on that? All of the other possible combinations of inputs are going to be false. Does everybody agree with me on that? Okay, so then it was posited that we could rewrite this as CD or C naught. Is that correct? CD or C naught. So then the question becomes, does that change this truth table at all? Does this change the possible values that could be true? What do you think? Somebody provide an example here that would be true under this expression that's not true under this expression. Somebody provide a set of inputs that would prove it one way or the other. So what if I just use all zeros? Would this be true or false under this expression? It'd be true, right? Would it be true or false under this expression?
False.
It'd be false because A, C naught is true, but A is false, so that ends up being false. This is false because C is false, right? So we can't simplify that. We can't simplify using that rule. I think, I forget who was just saying it, was you, was just saying it. It's slightly different. I look at this too and I think of that rule right away, but it's a slightly different formulation of that rule. I think it's something like C or A C naught equals C or A, right? I believe that's what we talked about on Thursday. So I believe this is in fact the simplest form. Did anybody else come to this conclusion? perhaps via different means, right? Wouldn't have to be the exact same steps. Probably many different ways. I actually found it interesting that she chose some Minterms form. It actually ended up being very nice, right? Very, very nice solution from some Minterms form. No arguments whatsoever, but typically if I'm trying to simplify something, some Minterms form can be kind of obnoxious to work with. Let's talk about some Minterms form actually for a second, or maybe go back a step farther and talk about some products form as well. So our original expression, as seen up here on the board, right, is not in sum of products form. What does it mean for something to be in sum of products form? What does that look like? No parentheses. That's so that's what I said in the video, and that's also kind of what the textbook was alluding to. It's a little bit misleading because I can really insert parentheses wherever I want, right? But it's a pretty good rule of thumb. To say that I don't need parentheses to express it might be a little bit more accurate, right? The parentheses might be there, but I don't necessarily need them. I can take the parentheses out and it's still equivalent, then it's in sum of products form, right? So really, the only thing we have to do to get this in sum of products form is what? I heard somebody say something. Distribute the D. So let's just distribute it. All right. There we go. And I wrote a parenthesis because why not? All right. So we are now in sum of products form, correct? So how do I get this in sum of Minterms form then? What do I have to do? Get this in sum of Minterms form. Yes?
You have to make sure that every variable is in every part.
I have to make sure that every variable is in every single term that I have up here. Right? Every variable has to be in every term. So in this term, for example, I'm missing the B. So how do I get it in there? What do I do? Yeah. Multiply by B or B naught. We have to do that for all of these terms. A naught, C, D, B, or B naught. Here it's missing the A, so B naught, C, D, or A, B naught. And then these two are missing multiple terms, so they explode. So for every term that you have, right? Every term that you have to add in, how many additional terms are you creating? Basically, it's a power of 2, right? So here I've got one term I'm adding in, that's going to turn into 2 ultimate terms. I've got two inputs that I have to add in here, that's going to turn to 4 terms, right? If I have 3 inputs missing, that's going to turn to 8 additional terms. It's really annoying that happens. That's that's algebra for you. What can you do? But so maybe I won't do the whole thing. Maybe I won't expand the whole thing out. But I'll write out the undistributed form at least, and then we can take a look at it and see. Oh wait, what am I doing? I need a C term here, so I'll add that here. Or A C naught. We're missing the B, and so this isn't sum of Minterms form, but it's at least a step in the right direction towards sum of Minterms form, right? I'm not going to distribute all this stuff out. I do have, a couple questions about this. For starters, how many terms are we going to end up with here when we're all finished? 12, right? Well, too many, yeah. 4 here, 2 here, and 2 here. That's 12 total. However, with some of Minterms, usually you end up with duplicates a lot of the time. Not always, but a lot of times you'll end up with duplicates. Does anybody see where some of those duplicates might come from here? So look for commonalities between some of these.
Well, second. Yeah, first one is second. A prime, B prime, C, D is going to be
A prime, B prime, C, D, right? So I don't need those twice. I only need it once. So I'm not ultimately going to end up with 12 terms. I suppose if we take the simplification as our basis, we should hopefully only end up with 8, right? Like I said, I'm not going to distribute all that out. I think it's kind of messy. I'll let you guys do that. But you should cancel those terms out when you're done. What's the point of all this? Why do we go through all this trouble? Why? What's the point of some Minterms? It just makes things more complicated, right? So why do we bother? Yeah.
It allows you to compare boolean algebra equations.
Yeah. Why is that? I mean, what's the problem? We could compare them before, right? But
Basically, if the expression is in some Minterms, then it's unique. So you can easily determine the two
Right.
equations are equivalent.
sure. If something is in sum of Minterms form, there is no other way to write it in sum of Minterms form that's different than how it's displayed. You can reorder the terms, right? You can use associative property. That's fine. But you will never have the same set of Minterms represented in a different equation, right? It's canonical form, right? With sum of products, we can't guarantee that. I can rewrite this perhaps a different way using sum of products, and it's a different expression that ultimately ends up being equivalent to this. Right? So sum of Minterms form is canonical. I can't rewrite this in such a way that doesn't use, that still uses Minterms and is different from what I have. Right? This is going to come in handy when I show you another way of simplifying expressions next Tuesday. So, yeah, that's to look forward to, which is nice. Any other questions about this stuff before we move on? Another one? All right, let's try another one. Here's a wonderful looking circuit. Give me a logic equation that this circuit represents. Try, you can, if you want to be clever and try to simplify stuff, you can. But let me give you a spoiler alert. I'm going to ask you to simplify this circuit on the next slide. So maybe try and keep it unsimplified to some degree so that you have some work to do on the next slide as well. Let me see what I can do. No, I mean, I will see what I can do. There are a lot of buttons.
Every day of neutral networks, our professor will see it every single time. He spends the first 5 minutes cycling the whole lot's time off because he can't figure out.
That's why I'm afraid. That's why I'm afraid to push any of these because it's going to turn the whole thing dark.
If you push all of the buttons, something's going to happen. We can say that with certainty.
The problem is it doesn't give me individual control. All I have are these presets. So I can't control like the individual lights.
That's right.
No, he's boss.
I'm sorry, I'm not sure there's nothing I can do.
basically just putting it. It's basically just defining it.
I first think
Reading this part.
I try so hard.
All right, who's got an equation for this guy? So tell me what to write up here on the board. Josh? A not, A and not B, and C, or A or B in parentheses, B or not what? Not D, and not C or what do you think? Good? Good. I like it. Try to break it down, right? So you can actually clearly see where each of the parts of this equation come from in this particular circuit. Like, break it down by the ors. I tend to break it down by ors. I just feel more comfortable doing that way. But you know, use whatever works for you. This is a direct one-to-one relationship. It looks like without any simplification. Cool. Alrighty. As promised, simplify this. Make it simple. Here's a hint. You can rewrite this circuit using 3 gates. Maybe a couple more than 3. Maybe 4 or 5. Let's see. 1, 2, 3, 4.
I thought you said 3 earlier.
4. I misspoke. You probably know which one. So you got it then? You got it? I think. Want to put it up on the board?
Like the whole, like,
I'd like to go through it step by step, yeah. I mean, it's kind of long, I know. It's not super long, though, is it?
This one just sits up.
That's more than 4, but so there's going to be something else.
Oh, you were saying and. Oh, wow.
It's okay. It's a step in the right direction.
Sort of.
We'll see if we can figure it out. In fact, I think you're pretty close. You're close. Just a couple more steps. You would have had it. Okay, so we got to start up here. Let's walk through what we've got so far. It can be even simpler. I know that much. Let's see if we can figure it out together. Let's walk through what we've got so far. What's happening in the first step and the second step? Just distribution looks like, just being distributed. So distributing everything, which makes it really, really large. Are there any terms that cancel? It doesn't look like there are any terms that are duplicates or anything like that. Oh well, that's too bad. We definitely
There were duplicates.
Oh, there were, you just took them out?
Yeah.
Okay. Good enough, good enough. All right, let's see if we can figure out what's happening between this step and this step. So this term is gone, right? This term's here, this term's here. This term is gone or modified. Oh, so I think I see what happened here, right? With a B and a B naught in these two. So we took those out using the same principle we saw before. Is that happening down here as well, maybe? AD naught, BD naught, BC. So what happened to these guys? I'm not sure where these went. Somebody help me out here. Yeah.
BC or BCD naught is just BC.
Ah, there you go.
And then
BC or BCD naught is just BC.
and then it's the same with ABD naught and
ABD naught and AD naught is just AD naught. Yes. Good. Thank you. I like that. That's good with me. And then what's happening between here and here? So this term is still here, this term's still here, this term's still here, this term is still here. It's the same thing, right? We've got ACD naught and AD naught, which just simplifies to AD naught. So this is good. We're definitely taking steps in the right direction, but we're not done. Can somebody suggest what else I might try to do? Yeah. Yeah, it's FOIL for sure. Or if you want to take it a little bit slower than FOIL, you could abstract it out one term at a time, right? Take the C out, for example. You end up with C times A or B, right? Or with B, or with A, B naught, or B, D naught. Right? And then I can also factor out the D here, right? So then that becomes this with the parentheses, or D naught, A or B. And then finally I see I've got this term in common between the two, so I can just factor that out. And what do I end up with? C or D naught, A or B. 1, 2, 3, 4 gates. Okay. 2 ORs, an AND, and an inverter. Takes care of this expression for us. Are there any questions? Yes. So yeah, there isn't really a name for this stop expression. It's in, horrible, nasty form. I don't know.
Are we always going to be the simplest form from
You should be able to, yes. You should always be able to get to the simplest form. Now, some paths are going to be harder than others, right? Which form you start with has a huge impact on what the simplification looks like. When Corey reduced from Minterms for that last expression, hers took a lot fewer steps than mine, because I started from sum of products form. It ended up being more complicated, even though I started with fewer terms. Because sometimes those extra terms can help you cancel other terms out a little bit faster, right? Sometimes you need to add things in order to be able to cancel things out. So, yes, and I can't really give you any rule of thumb as to what you should start with. I always tend to start with the one with smaller terms, because it seems like it would make more sense, but, it's not always going to be the case. You should be able to always get there, no matter what. I mean, because if you consider worst case scenario, what am I going to do? I'm just going to convert to Minterms and go from there, right? I can always go to Minterms and go from there. I can start with any equation and go to Minterms, and then for Minterms, I should be able to always get to the simplest version no matter what, right? Because Minterms is a canonical form. Yeah. So, any other questions about this? So I haven't actually, I did ask you to do on the slides. I don't know if I'll do it on the board or not. I did ask you to use a truth table to verify this expression, right? How many entries does my truth table have for this equation? many different entries? 16. I have 16 different entries, right? So that's part of the reason why I'm not drawing it on the board, because that would get pretty large pretty quickly. But hopefully you understand the process of converting those things into a truth table if necessary, right? You just have to try at all possible combinations and then plug them in, right? In fact, that'll kind of help you out for this last one, which I would like to take some time to talk about. Maybe take another couple minutes. If you haven't done the timing diagram one already, I'd really appreciate it. Take a couple minutes and try that one out. And we'll go over it. Or if somebody has done it and wants to come sketch theirs up on the board, that would be cool too. Let me know. Any takers? Use this expression, please. Don't use the original one. It's a little simpler. Do I have any takers? Put this up on the board for me. Any volunteers? No? You make me do it? I can do it. That's me making a mistake.
So it doesn't depend on the previous one.
Nope. It does not depend on what the previous one was. Yeah. That's just me screwing up. Does that change my output? No, it doesn't. Thank you. Yep. Did I make any other mistakes? I think it's good. Okay. So what happens, right, in these timing diagrams, we just see the signals changing. Now, I tried to keep this, the distance between the changes somewhat consistent. That's going to become a lot more explicit when we start talking about sequential circuits after the first exam. What's the difference between combinational and sequential? That was in the textbook, was it not? Or was that next time? How could we think about next time? Next time? All right, we'll talk about that next time. Anyhow, yeah, so I also asked you to create timing diagrams for the first lab, so it's good to be able to write these out to know what they should look like, to know how to interpret them. And just to give you an idea, this entire thing that we just went through was an exam question in years past. So just to give you an idea of what's coming up. Because the exam is coming up pretty soon, right? 2 weeks or so? 2 weeks from Thursday, I believe, is the exam. Okay. Any questions on any of this stuff? We got time to do some more. So let's do this. I believe this is the last one I brought. So let's take a look. You're given the following truth table. So now we're going to go the opposite direction. You're given the following truth table. I want you to construct a logic equation out of it and then simplify that and make sure that the truth table for the new one works with this one, right? Take a few minutes, talk to your neighbors, and then we'll go over it in a little bit. Okay, so real quick, this first part, constructing a logic equation, shouldn't have been taking too much time. So just so that we're all on the same page, all right? What's the process? How do I construct a logic equation out of a truth table like this? What do I do? Somebody explain for me what needs to happen? Yeah.
Look at all of your outputs that are one. For every output that's one, figure out which input it creates that one. So for the first one, you have 0, 0, 1, which corresponds to A naught, B naught, C.
Perfect.
And you just do that all together and pour together all the ones.
We just pour together all the terms that we can construct that have a 1 in the output column. So we've got A, B naught, C as the next term. And then we've got A, B, C naught as the next term. And then finally we've got A, B, C. What form is this? Sum of products is technically correct. Sum of midterms is a little bit more accurate. It is sum of products, right? Sum of midterms is also sum of products. But sum of products is not necessarily sum of midterms. So here's our starting equation. Now take a few more minutes and see if you can simplify this out. If anybody gets it and wants to put it up on the board, please let me know. You got something? Okay, take a crack at it. We're going to talk about consensus. Have you ever seen No, but there is something that you can do. Stop making that mistake. All right. This one wasn't so bad, right? What do we have? We're looking for terms that are differing by just one input value, and then we can cancel that value out. So here, the term that differs is A, so that A can get pulled out and go away. Here, that term is C, so that C can get pulled out and go away. Could this be simplified anymore? I think I just told somebody it could when it couldn't. My bad, person. That was. This can't. This cannot be simplified. This is the same thing that we saw earlier, right? It can't be simplified any further. That's it. It really looks like, you know, like you see that and you really want to, but no. Exactly. Yeah. Can't do it. Can't do it. Cool. All right. I do want to take a step back to. There's one very important thing from last time that I wanted to talk about that we ran out of time to talk about. We have 15 minutes, which is just the perfect amount of time to talk about this. Who can explain the consensus theorem for me? It's a very important rule. I want to make sure we spend a little bit of time on this. Consensus theorem. Who can state it for me? I know this is from last time. Yeah.
It's xy or x naught z or y z.
And what happens to this?
Is equivalent to xy or x naught z.
Perfect. Prove it.
Well,
I didn't mean you specifically.
I do have the proof for you.
Well, fantastic. Yes, fantastic. Well, for everybody else, take a few minutes and prove it, and then we'll talk about it in a few minutes. We ran out of time to do this last time. those times, just to give you a little hints where you may need to make it bigger or you can make it smaller. All right. Who wants to write their proof up on the board for me? Anybody? Want it? So while he's doing that, let me just say for a couple things in preparation for what's coming up. So since we do have the exam coming up relatively soon, this is the last real super theoretical section. You notice I spent 2 class periods on Boolean algebra. That was not an accident. Some people don't like Boolean algebra. I'm sorry, but it's so useful, right? I guess we do have one more theoretical-ish section coming up next week, but from here on out, it's going to be practical all the way down. So we're going to talk about VHDL on Thursday, and then from then on out, after the first exam especially, we're just going to be building circuits like crazy. We're going to be building circuits left and right. So thank you for your patience to this first theoretical section. I promise it's going to get more exciting. It's really, really important that you know this stuff because we're going to be applying these concepts all over the place when we start building circuits. So theoretical ends kind of nowish. Practical section is coming up very soon. That means the first exam is going to be pretty theoretical-ish as well. And then the exams from then on out. Exam 2, exam 3, I might ask you to write a little bit of VHDL code, right? Stuff like that. So for those of you who are itching to write some code, it's coming very soon, I promise. Alrighty, let's see how things are going up here. Looks like we got it. All right. So let's take a look and see what's happening. Who can tell me what's happening in this first step? What are we doing? Converting it into Minterms, some Minterms form, right? Seems like a reasonable first step to make. And then over here, it looks like we've got some duplicate terms. Is that correct? Yes, we do. We've got some duplicate terms that we can eliminate after we convert to some of Minterms form, which is all well and good. So then we're left with these 4 terms, and what happens? We've got that pattern that we like to see, where we've got 2 terms that are exactly the same except for one input that's the opposite. Here we've got the same thing with y and y naught. So we can take those out, and what are we left with? We're left with the proof of the theorem. Right. Cool. We have 10 minutes left. If you want to stick around and work on homework, if you want to stick around and work on more practice problems, I will be here. Elliot will be here. Sorry, Elliot. We'll hang out until 5:30. Otherwise, I will see you on Thursday. We'll write some code.
The lab is the only homework, right?
Lab is the only homework for right now.
Partners are optional or are they mandatory?
No, they're optional. Yeah, they're optional.